Between 1917 and 1950, one man was nominated for the Nobel Prize in Physics 84 times, and 84 times the committee gave the award to someone else. It is an unbroken record of rejection in the history of science. That man was Arnold Sommerfeld. With his fencing scar, thick mustache, and stiff Prussian posture, he looked less like a disheveled academic and more like a colonel in the cavalry. While Sommerfeld never won the gold medal himself, the people sitting in his classrooms did. 4 of his doctoral students, including Werner Heisenberg, won the Nobel Prize, followed by 3 of his postgraduate students. His peers recognized his immense value. Albert Einstein wrote to Sommerfeld to confess that, if he had the time, he would sit in on his lectures to perfect his own mathematical knowledge. Einstein specifically admired Sommerfeld's unique ability to pull young talent out of the soil. Understanding his story reveals the quiet, rigorous labor that transformed those speculative early theories into a precise, functioning universe. Sommerfeld began his career far from the cutting edge of quantum mechanics. He grew up in Königsberg, Prussia, where he earned his doctorate at age 23 as a mathematics prodigy. He spent his early 20s consumed by classical differential equations. He also completed his mandatory military service and continued as a volunteer for 8 more years. This time in uniform ingrained a deep, systematic discipline into his daily routine, a rigid structure he would eventually bring into the laboratory. By the time he took over the new Theoretical Physics Institute in Munich in 1906, the scientific landscape was fracturing. Experimental physicists were discovering strange behaviors in atomic particles, and the strict classical rules of the 19th century were rapidly breaking down. Niels Bohr proposed a major solution with his atomic model, suggesting electrons orbited the nucleus in perfect circles. It was a massive leap forward, but those simple, circular paths lacked the deep mathematical rigor required to explain the complex behavior scientists were observing. Sommerfeld realized that the abstract world of the quantum required the precision of old-world calculus. He set out to apply that mathematical discipline to Bohr's chaotic new frontier. Sommerfeld proved that electrons do not travel in perfect rings, moving instead in complex elliptical orbits. He introduced the azimuthal quantum number, a specific mathematical tool giving physicists the ability to calculate and define the exact shape of the shifting elliptical orbits seen here. Armed with this new framework, he turned Munich into an intellectual powerhouse. He published his lectures into a textbook called Atomic Structure and Spectral Lines, which became the definitive text for an entire generation of physicists. Despite his imposing appearance, Sommerfeld ran his institute with an open door. He treated his young students as peers, encouraging them to question established theories, and he even bought them boxes of cigars to fuel their late-night physics debates. Sommerfeld directed his genius toward engineering an interactive environment. He built an intellectual incubator that systematically trained young minds to dismantle the complex interactions of multi-electron atoms. In the 1930s, this collaborative network came under attack. Sommerfeld was disgusted by the rise of the Nazi regime and fought to protect his Jewish colleagues and students from a group of ideological fanatics pushing a so-called German physics movement. Around this same time, the puzzle of his missing Nobel Prize became impossible to ignore. Historians have speculated that rumors of a quiet rivalry with Niels Bohr may have kept the voting committee from recognizing his work, but the actual files reveal a deeper institutional bias. The Nobel Committee consistently preferred to reward lone discoverers who found a singular breakthrough. They repeatedly passed over systematizers, the people who synthesize data, write the textbooks, and build the frameworks. The award system was built to celebrate isolated flashes of brilliance, often ignoring the foundational architects who make that brilliance possible. Sommerfeld's life ended abruptly in the spring of 1951. At 82 years old and struggling with his hearing, he was struck by a truck while walking near his home in Munich. Following his death, his student Max von Laue summarized his legacy. Looking back at the golden age of physics, von Laue observed that Max Planck was the authority, Albert Einstein was the genius, but Arnold Sommerfeld was the teacher. His detailed models established the baseline for the next 50 years of research. His calculations on electron behavior in metals laid the exact mathematical groundwork for modern solid-state and quantum physics. Sommerfeld's legacy is measured in the 84 names on the Nobel ballot.